Hello. Next, we are going to look into basic data types. When you declare a variable in Python, it needs to have a certain data type. Python is dynamically typed, so Python automatically decides what kind of data type should be used. Let's look into this. We create in our Jupyter Lab, just a reminder, we started from our Anaconda Navigator, we started the Jupyter Lab. This opens up, and in our notebooks folder we have used previously, we create a new notebook. Right click here to rename the notebook to basic data types or something. Another nice feature about the Jupyter notebooks, and I'm gonna disperse a little bit more information on how to use them ideally throughout these videos, is you can use markdown cells in conjunction with code cells to basically pretty up your code a little bit and give more explanations. What I mean with this is here's this drop-down menu on the top where it says code, meaning the current active cell is a code cell, so it's supposed to be Python code in there. You can change this to a markdown cell. Then you see the numbering vanishes, and Markdown is kind of a, it's a markup language, markdown language, meant to be human readable text files that are rendered in a pretty way. Meaning we can give headlines, for example, like a big headline with one hashtag or £sign in the beginning. So we can give the first order heading similar to HTML. It's quite similar to HTML. Let's call it data types. Then we can make a second order heading by 2 hashtags and call it, for example, integers. Let's go with integers first. If I now execute this, Shift Enter, it is rendered in a nice way. You can obviously double click or enter to edit, write some normal text here, right? And then you can also import pictures. There's a special markdown help pages or cheat sheets where you can look up how to do this. Just as an example, you can also include, which is quite nice, LaTeX code, formula code. For example, int from 0 to inf f of x dx, and this renders nicely in a LaTeX formula. So it's quite nicely done to include more information on the code you're running and maybe drop in a formula as a reminder, some summary of results that you just found out. So it's all nicely tied in one place. Okay, but this is something not something we need right now. So let's maybe delete this again here. Integers, data types. So Python, as I said, is dynamically typed. Python tries to decide on its own what kind of type a certain variable is. If you're not sure about what different data types in general are, independent of programming languages, it's basically an internal representation in the computer that tells the computer how to interpret and how to deal with certain types of data. For example, an integer is the number 1. Let's call it a, is 1. And then if I just print a, give it like 1 is given back. If I now check what the type of a is, the type is the data type, it's an integer, meaning a whole number. There's no fractional numbers in integers. It's just 1, 2, 0, 1, 2, 3, and so on. There's also signed integers, -1, -2, -200, whatever, but always whole numbers. The next type, if you, for example, divide 1 by 2, divide 2 integers by each other, you will get 0.5. It's not displayable or expressible as an integer anymore. It's a fractional number, and this is a floating point number, represented as a floating point number in Python. Since Python version 3, if you divide two integers by each other, so 1 divided by 2, sorry, is 0.5. So Python automatically recognizes that the result, what you want to do, is that you want to have 0.5 as an outcome and not 0. Because if you stay in the integer space, basically, so if you stay in integers, you can't express 0.5, meaning you would get 0. For example, if I force 1 divided by 2 into an integer, the result is 0, because it's rounded to the next lowest number. Okay, I can switch between, so f, for example, like a floating point value, is if I can force any number to be a floating point value if I include the dot, like the decimal dot, and then I type type of f, and then I see it's a floating point number. And this is in most cases it's automatically taken care of for you by Python. If you are in a position where you have to be conscious about which data type exactly you use, Python has options for this, but this is something to deal with later. If you're using different modules, more advanced modules like the numerical Python, NumPy or SciPy, it also extends this range of normal 8-bit floating point values or 16-bit floating point values that the standard Python comes with, to, for example, 64, 128-bit floats that can display very small and very large numbers that might be useful for you in calculations. But if you need them, basically, you will probably know that you need them and look more closely into it. Okay, so these are integers. Escape in this cell here, escape A includes another cell above, A for above. There, if I hit M, just not in the cell, in the edit mode M, then it's just printed M. But if I escape and it's not in edit mode, this cell, and now I hit M, it's turned, as you can see here, into a markdown cell. So I can give it a new title here, floats, or floating point numbers. Maybe column floats. And here, maybe let's call the integers ints. Okay, the next data type, quite important, booleans. So escape M to turn it into a markdown cell, 2 hashtags, and then booleans. If you haven't heard of booleans, it's basically a data type which has only 2 states, 0 and 1, or true and false. So let's call it B equals true, right? If we now do type of B, this is a boolean, a bool. Boolean means I can do Boolean arithmetic with it. I can do operations on this. Obviously, I can also do arithmetic with the integers and the floating point values, as we had before, 1 divided by 2. Right? I cannot divide a true divided by false. So I can try, but this is not a 0 division error, because false is 0, is equal or equivalent to 0. I could try the true, the false divided by true, gives me a 0, but there's no real meaning behind it, because in our case, false is 0 and true is 1. This is kind of an equivalent formulation of the booleans. However, other operations make much more sense. For example, if I have another variable here, maybe A equals to false and B equals to true, and then I do A is equal to B, that does not make sense. Because this is still orange, so I didn't execute this, and I see after the number 8, 9, and so on. I didn't execute this cell actually, and A was still the number 1 here. So 1 is true, yes, because 1 is true and 0 is false in this Boolean sense. Okay, so if I execute this cell now, A equals afterwards, A is now, I can check, A is false and B is true, right? Escape, and X, by the way, deletes a cell, X. So now if I type A equal B, the result is false, right? Because A and the equal sign means compare A to B, and it's not the same, so it's false. Booleans become very important when you compare numbers. For example, you have 3 is smaller than 4, right? The result will be true, yes. 3 is smaller than 4, right? But if you look at the type of this result, then it's a Boolean. So the result of a comparison of two numbers is always a Boolean. And this is the same for equal. Is 3 the same as 4 is the question, and the result is also a Boolean, the type, and the result is actually false, obviously. Okay, so normal arithmetic rules apply. Let's quickly go through the operators, maybe, because they are quite important. Operators. So normal operators is 1 plus 1, right, is 2. I have, we had this already, 1 divided by 2 is 0.5. I can also force this to be it's good style to if you want to work with floats, to declare that you want to work in floats, right? You can also do like a multiplication, right? 2 times 3. You can do division, we had already. Minus is the same as 1 minus 1, right? It works the same. So first one is 2, second one is 0. And then the power, so to the exponent, basically, is a 2, and then 2 times the multiplication sign. 2 is 2 to the power of 2, which means 4. There's no sign, no operator for standard operator for square root, but you could obviously do 2 to the power of 0.5, square root of 2. That is something you can do. Okay, these are the basic operators for doing arithmetic. Obviously, we had already 3 is smaller than 4 is a Boolean, right? And 4 is greater than 5. It's false, but it's the greater, smaller and greater signs. Apart from the smaller than and greater than symbols, you have also greater, equal, and smaller equal. Right? And then you have the question mark, basically, like is it equal, right? Because one equal sign means it's a variable declaration. A equals 1 defines sets the variable a to be 1. But let's do this, and now we can ask a question. A equal 1 gives you back true, because yes, after we set it to 1, a is equal to 1. So this result is again a Boolean. Any from these comparison operators, let's call them, will give you a Boolean back. Okay. There's a couple of more operators that you can use. The mod operator is the % sign. So 5 mod 5 gives you a rest of 0, so it's 0. The modulo, if you use it, but this is a bit advanced, I think. You can have also kind of compound data types, meaning, for example, a list. A list is a collection of different entities that have their own data type. So let's go into this, escape, and by the way, if you want to add more cells to something, go out of edit mode, so that there's no blue border around it, escape to get out of there, and then either A to enter a new cell, an empty cell above, or a B to enter a new cell below. You can also do this with this little plus sign here, insert cell below. Right. Okay, escape M to turn it into Markdown and make a new headline. Let's call them lists. A list, let's call the list A, is basically defined by square brackets. There's also something like tuples with round brackets, but we'll not go into too much detail about those. So lists is quite an important data type in Python. So anything can be put into a list, and they also don't have to be the same type themselves. So for example, I can do a list of 1, 2, and then 3.0, right? I can do also, we'll get to those. Maybe you should do them first. So hello, this is a string. And this can be any object, basically, that is its own object, can be put into a list in Python. So if I now look at the list, it prints me this out, and I can access individual elements of a list, again by L of square brackets, and then Python starts to count at 0. So L of 0 would be the first entry, the 0th entry of L, and this gives you 1. And if I now do type of L of 1, this is an int, because the 1 is an integer, or Python recognizes 1 as an integer. If I do type of L of 2, so this is 0, 1, 2, right? Third element, number 2. If I do this, it's a float, because 3.0 is a float. Right? And if I do L of 3, the next one, it's a string. We haven't had strings before, so let's go here, escape A, and A again, enter here, and type strings. Escape M, turn it into a markdown cell. Yes. So strings S, for example, we had this already. Hello. There is escape A to add a couple more cells here. There's a certain arithmetic you can do with strings, which is quite useful. For example, if you want to append strings together to form a file name, for example. So first of all, a string is something like a list. So a list is a collection of objects, and a string is just a collection of individual characters. So S of, similar as we had for the lists, right? S of 0, so the 0th entry, the 0th element in the string S is H. So I only get the string H back. The result is then also a string. So, the type is a string. So there's no such, there's no distinction in Python between characters and strings. So in some programming languages like C or Fortran, you would have a character set and then, or a character data type and a string data type of different lengths and so on. Not so here. Everything, if it's a string in Python. It can have a specific size, but it's always a string. And it's like a list of characters. Meaning you can also index individual or multiple of these. So for example, you might recognize this notation from something like, if you used MATLAB before, it's quite similar. So you can do everything with double dot or colon. You can do everything until, for example, the third element. This is HEL, 0, 1, 2, right? And then until everything until the third, the second L, is given back. Right? You can also do just the 2 to 4, for example. This gives you just the second till the third entry in this thing. Same thing applies to lists. So if I do L 2, 3, right? Colon 3. This gives you just 3 because from the second element 0, 1. From the second element to the third element, but not including the third element, is just this number 3. If I do until 4, I give a part of the list back, the second half of the list back. There's also an abbreviation in both cases. So if you want the whole thing back, the whole string, for example, use just a colon, gives you the whole thing back. If you want to count from the back, so from the end of the string or from the end of the list, you can use negative numbers. So for example, you could use everything until the last entry, not including the last entry. And this gives you HELL, like here, because everything until the last entry, -1. Obviously, -2 gives you then HEL. This works also in lists. So here, let's do L of, for example, everything until -3 gives you just the 1, because we have 1, 2, 3 items, and everything until the last 3 is just 1, and so on. You can also combine these, so the first element until the second to last element is empty. It's an empty list because there's nothing left, right? If I start at this first and go until the -3rd, there's nothing left, so it gives you back an empty list. Lists, let's go back to strings for a second, because they're quite similar, strings and lists. Let's do it with strings because it's more intuitive, I think. Escape and B to enter a new cell there. And if I want to now, can I add strings, for example? Yes, I can. S plus S, right? In our case, S is still hello, and S plus S is then hello, hello. So it's just concatenated two strings together to form a new string. The quotation marks here indicate that it's again a string. We can also check the type. And this is a string. Right? So I can also multiply strings, not by other strings, but I can multiply strings by integers, for example. S times 3 gives you hello, hello, hello. Just 3 times. It's equivalent to S plus S plus S. Right? That's why it works. But you have to somehow, if you, for example, want to declare your own data type, you have to implement these operators for your specific data type, or at least declare how they should be used. But in case of strings, this is quite easily possible. So you can imagine how interesting this would be if I, didn't want to execute this. So let's make a first one string /home/ not Matthias, that's me, tutorial, that's my home folder, right? And then I know I'm in the notebooks folder here, so my second string S2 would be notebooks. Right? So I have now two, escape A to enter a new cell. I have now two lists, S1, and two strings, S1 and S2, and I see if I print them out, the first is home tutorial and the other one is notebooks. I can, however, just add the two together to make a new file name or a new path, home tutorial notebooks. As easy as that. You shouldn't use if you want to construct paths or file names with paths, you shouldn't do it this way. And there's a special kind of function for that. Maybe we should quickly introduce this. So file name, this would be a folder, basically, a path to a folder, and this would be then the file name or another folder, whatever. Right? You can do the same thing because now you have to, for example, have the slash here, or in Windows the backslash, doesn't matter. You have to remember that here there is a slash if you want to turn this into a file name, right? If you remove this slash, this trailing slash, and do the same thing again, it's not automatically included here. So you have to be very careful about this, where you do this. If you want to use this for file names, I can only recommend to use the OS module. So import OS, right? And then you have in the OS module, you have the path functions, collection of functions, and this has a join function. And now I can do S1, S2, right? And the result will be home tutorial notebooks. It doesn't matter if I have a slash here a trailing slash or backslash in Windows, and do the same thing here. It automatically recognizes that I want to concatenate one path with another path and automatically takes care of the slashes. So the path join functions, this is how you actually should do it. However, if you want to construct a file name, for example, escape B to enter a new cell below, and then we have S2, S3 is something like, just call it file, right? And then the S4 is something like the ending .dat or something. In this case, obviously, it makes sense to do S3 plus S4. And this gives you just file.dat, because there shouldn't be any trailing slashes in there. Okay, so in this case, this is working with strings. It's quite useful. Okay, so lists, as I said, can take not only, as a string is a list of only characters, lists can take any object in them. And they are ordered. So if I create an empty list, let's call it empty list. I can do this by just adding, just writing square brackets, square empty brackets. And now if I look at empty list, by the way, auto completion. So if I just do EM and tab, it will pop up automatically. Shift enter gives you an empty list. I can now add something to this list, not add, but append something to this list. So I can extend this list with the append function. If I'm not sure how this is called, I just type the dot and then the tab, and then I get a selection of possibilities that IPython thinks is possible for this type. And it's a list, so it has a certain functions attached to it. Clear, copy, we'll get back to copy, extend, count, index, and so on, sort, and also here in the beginning one append. So if I append something like the integer 1 to it, right, and I now look at empty list, then I see the integer 1 is in the list. If I do something else, hello again, a hello string, right, attach it, and now I look at empty list. It's not empty anymore, poor choice of words, but it has 1 and hello in there. So you can append to an empty list or to an existing list, you can append certain elements, which is quite useful. Okay, let's make a list. Let's call it my list, and it just has the 1, 2, 3, 4, 5, 6, and then comma maybe 2, 2, 3, 4 in it. So it's a 1 through 6 and then 2, 3, 4, something like this. If I look into my list, it's ordered in a specific way, in the way I created it. That's why the append works. So I can now do dot append and then append the number 10 or something, and now my list has the number 10 appended to it. However, if I want to, this is sorted in a specific way, right? Structured in a specific way. I can use, if I remember here, dot tab gives you a selection of possibilities here, and there is the sort function somewhere, in the end, sort. If I do this, shift enter gives you an error, or not an error, but it's just a declaration, okay, this is actually a function. I'm not doing something, I'm just giving you the feedback, this is a function. If I want to execute the function, I have to call it with round brackets. If I do this and print my list again, then I now see, previously it was called 1, 2, 3, 4, 5, 6, 2, 3, 4, and now it's 1, 2, 2, 3, 3, 4, 4, 5, 6, 10, because we appended 10 also. And it's ordered from smallest to largest. Also alphabetical ordering if you have strings, for example, in there. So the sorting changes the order of things in your list, or the sort function changes the order of your list. Yes, there's other functions like index, for example, that are quite useful. So index, if you want to know at which position the number 5, for example, is, right? You could just index the number 5 and get 7 back. So that means my list, and then square brackets of 7 is 5. So the entry, the element at position 7 is 5. Right? Or the index is the other way around of this question. So at which position in the list is the element 5? Right? Same thing works for if it's a string, right? We had this empty list. Empty list, it's 1 and hello in this list, right? I can do an index of this list and search for the word hello. And it gives me 1 because the first entry in empty list is hello. The 0th one was 1. Okay. That's enough for now about lists, I think. We're going to be using them heavily. You are going to be using them heavily. And they're quite useful to store a lot of information in there. However, if you want to calculate with them, arithmetic with lists. So we had this, for example, we have now 2 lists, empty list, empty list and my list. Right? 2 together. So we have now 2 lists, 1 hello, 1 to, and so on. I can, of course, add them together. So empty list plus my list is just concatenating the 2 together. Right? That is possible. Like a multiplication, for example, doesn't make sense. It can't multiply. The error message, by the way, is quite, you have to read the error message, and sometimes they are really helpful. Can't multiply sequence by non-int of type list. So what it's trying to do, he tells me in this first line in this cell, the empty list times my list, right? I can't multiply by non-int. So he wants to multiply by something, and this is a non-int, so not an integer, to a list. And obviously, because this is not an integer, actually one of them is not an integer, that doesn't work. If I turn this into an integer, then obviously it works. 3 times, so just empty list plus empty list plus empty list. Okay. Let's go now into another very important kind of meta object where you can also put different things in it. Similar to lists, but lists are ordered. If we don't want a specific order, a specific structure to an object, we can use dictionaries. So escape M to turn it into a markdown cell, enter, hashtag, and then dictionaries. Very powerful. In other programming languages, escape BBB. In other programming languages, dictionaries are sometimes in Java, for example, JavaScript are called hash tables, I believe. So they have different names, but they are the same, have the same concept. So it's kind of a named list, a named, non-structured, not structured, or non-ordered list. So let's call it our dictionary D, and compare that in the previously the list was square brackets, right? Every time you see square brackets, it's a list. And in the dictionaries are curly brackets. So if I say D equals just curly brackets and I do type of D, I get a dictionary. So dictionaries can be similar to lists but different in other ways. So for a dictionary, the order doesn't matter. However, instead of a fixed order, 0 element, first element, second element, third element, and so on, you have names or keys in a dictionary. So, for example, I can use a string 1 as a key, right? And then with the colon, double dot, I assign to this key some element. And this can be anything. This can be, for example, hello, right? A string. Then I can do a second key, number 2, and assign to this key the float 2.4, whatever, right? The type is still a dict. And now if I print D, or the dictionary, I see this. But how do I access these? Similar as with the lists, but instead of because the order now is not fixed anymore. It depends on how this dictionary is actually written into memory, what the order is. But we have the names. The first entry here is just called 1, and the second entry is called 2. So if I want to access the element with key 2, I just do D of 2, and this gives me back 2.4. If I want to do D of 1, it's hello. They actually don't have to be strings, so I can also give as a key an integer, for example, or any other object actually. So if I execute this again, the type is still a dictionary. D of 1 is now not possible anymore because we changed D, so there is no key string of 1. Right? If I try this, I get a key error. 1 string of 1 is not a key of this dictionary. However, if I now do the integer D of 1, I get the correct hello back. In dictionaries, let's make another one. Let's call it another key, and let's call it list. And this is, let's call it some list, just to make it sure, make sure that it's something different. So some list can also be a list. So 1, 2, 3, right? And now D of some list, right, gives you back a list. This is kind of it's a dictionary which includes a list, and because this gives you back this as a result of D of some list, gives you back a new entity, and this is what's printed out here, and this is again a list. So when I do a type of D of some list, it's a list. Now, because this is a list, I can access each individual element now, similar as I accessed the list elements here, by just typing, for example, 0. So that's the 0th element, the first element of this list, which is behind some list in the dictionary D. 1 would be the first element, so 0, first element of this list, some list in the dictionary D. If I do this, it gives me back 2 because the entry here is 2. Similarly, this also works for lists, because as I said, in a list anything can be in the list, like a string or a float, right? It can also a list can be a part of another list. In this case, you would call them nested lists or nested dictionaries. Also, a dictionary you can create a dictionary of dictionaries. That might be useful in some cases. Just look out for nested dictionaries or nested lists. Okay. I think that's everything about the basic data types I wanted to share with you. Let's go, or when we're talking about numerical Python, obviously it's quite tedious to work with normal lists, because I can't do arithmetic as we showed here. I can't multiply a list. If I want to, for example, have a number, an array, a vector of numbers, and multiply element-wise by 3, I can't do this with a list, because the list would just give me 3 times the list back, right? So in this case, we're dealing with arrays, and we have a special kind of data type for those, NumPy n-dimensional arrays. We'll get back to those and more specific data types later. So as a final thing, maybe just let's call them maybe object data types, because there's other data types that are, maybe you can also declare your own data type at some point. But what we had already was the datetime object, right? The datetime module. Let's call import the datetime as dt, and now we had the dt.datetime of, let's say, 2021 comma 12, comma 24, Christmas, and let's call it D, right? Or let's call it T because it's a time, right? Or a datetime object. So if I now print T, it gives me back datetime of the 21st of December, 2021, December 24th, 0 o'clock, because I didn't specify the time. Okay, and if I now do type of this, it's not a string, obviously, right? It's not an integer, it's not a float. What is it? It's actually a datetime object. So it's a datetime object from the datetime module. And this has some special properties. For example, you can't multiply t by 2, right? What should that mean? Multiplying a date by 2 doesn't make sense. So it's not implemented, the multiplication with an integer. If you want to, however, add something to this, you can use another specific data type, for example, and this is also a datetime data type called time delta. And this has an option, for example, seconds equals 5,000. So this is 5,000 seconds after the 24th of December 2021, because we added these together. So t plus a delta t of 5,000 seconds gives you then 1 o'clock, 23 minutes, 20 seconds after 0 o'clock, so 12 o'clock at night, which we had before. Okay, just as one example of how you can create different data types, how different data types can be used maybe, and you always have to watch out how to implement the operations that certain data types can have. With the basic data types, they function in a way that you would assume they would, right? So if you wanted to, if you divide 2 by pi, right? It's an integer divided by a float. It gives you back a float because you assume this is what you want. Right? Okay, that's it for now about the data types. In the next video, we're going to go into a little bit about conditions. We had these already with the Booleans, so that's a nice connection to the data types. But also, where Booleans are very useful are if statements or questions like if is something, do a specific type of operation if some condition is true or not. See you soon.